Hello everyone, welcome to this video. In this video, we will perform the short circuit test on a linear transformer. So in the previous video, we built this circuit, and this circuit is for the open circuit test. As you see, the secondary side is open circuited of the transformer, and the voltage which is applied to the primary side of the transformer is the rated voltage. Now we need to perform or modify this circuit in order to perform the short circuit test. So what we need to do is to short circuit the secondary side of the transformer. So now I'm short circuiting the secondary side of the transformer and you need to apply a small voltage. You need to apply a small voltage, and I will start with 10% of this voltage. So I will multiply the voltage, the rated voltage, by 0.1. I will do apply and OK. So by definition, the short circuit test is a test where the secondary side is short circuited and you apply a small voltage so that the current will be the rated current in the circuit. So let's see what will be the rated current of this transformer. So we do double click on the linear transformer. So here is the power of the transformer. So it is 250 megavolt ampere. So it is 250 megavolt ampere. And here is the voltage, the primary voltage of the rated voltage. So what we need to do is to divide this 250 megavolt ampere by 735 kilovolt ampere. So this is what I will do now using my calculator. Since this is a single phase transformer, so what I'm doing is to divide the apparent power, which is 250 megavolt ampere. So it will be 250 megavolt ampere and divided by 735 kilovolts. And the answer is 340.1 amperes. 340.1 amperes. So this will be the short circuit current, and it should be equal to 340.114 amperes, like this. So we need to keep increasing this small voltage until we get this number, until we reach the rated current. So now I have this number calculated. I have applied a small voltage, which is 10% of the rated voltage, and I want to run the circuit. So I'm clicking run here, and I see that the current is only 212. So I need to raise the voltage until I get 340. So now if I raise the voltage by, let's say, another 5%, so I will do apply, OK, and do run again. I see that I'm closer to the 340. So I will do another 1% like this. Apply, OK. And I see that I'm very close to the current. So let me add another, let's say 00 and 55. I will do. So it will be a little bit more than 16% of the rated voltage. And I will run the circuit again. I see that I'm still behind the 340, but very close. So we can increase a little bit. So let me do this as 6 here. Apply, OK. And I will run the circuit again. I see that I have this number already, 340.2, which is very close to 340.14. Okay, so what I have now, I have the short circuit power. So this now short circuit power, and this will be short circuit voltage. And this will be the short circuit current. And as you see, the short circuit current should be the rated current. How we do find the rated current? You divide the rated power by the rated voltage of that side on which you are performing the experiment. And we are performing the experiment on the primary side. So we are dividing by the primary voltage. Now we have this power, we have this current, and we have this voltage. We can calculate R equivalent primary. So the equivalent resistance referred to the primary side, and we can calculate the X equivalent primary, which is the equivalent inductive reactance referred to the primary side. And we need to compare them with the parameters of this model. So as you see here, we have this value, which is R1. So this value, 4 point something, is R1 in ohms. And this value, 0.79, is R2 in ohms as well. So, and the resistance that you are calculating using the short circuit test is R equivalent primary. So what you need to do is to refer the secondary side resistance to the primary side and then add it in series with the primary side. And how we do refer the secondary side resistance to the primary side, you need to multiply it by A square, where A is the transformation ratio. So A will be V primary, this voltage, divided by V secondary by this voltage. So 735 kilovolts divided by 315 kilovolts. So this will be the transformation ratio. You take the square of this transformation ratio, you multiply it by R2, and then you add it to R1. So this will be the value that you will have, or that value that you can compare with the R equivalent primary that you will find in your calculation. Similarly, for X equivalent primary, so as you see here, we have the inductance, we don't have the reactance, and here we have also the inductance. So what you need to do is first to multiply this inductance by 2 pi f, where f is 60 hertz. Then you need to multiply it by A square in order to refer it to the primary side. And then you need to add it to the reactance of the primary side, which will be this inductance multiplied by omega, or 2 pi f. So this will be the inductive reactance referred to the primary side, and then you can calculate it with the parameters calculated from the short circuit test. So these two parameters to be compared by the open circuit test, and these 4 parameters to be combined into 2 parameters and compared with the short circuit test calculations. So this is actually everything about the short circuit test. In real life, you need to be careful not to apply a voltage while the secondary side is closed, unless you are sure that this voltage is a very small voltage. We start usually with 8% of that voltage, 10%, and then you will see whether you need to increase it in order to get the rated current, or decrease it if the rated current, if the current here is more than the rated current.